Good morning, class. We are looking at analytic trigonometry, trigonometric equations. So we're going to look at trigonometric equations and then trigonometric equations involving identities, sum and difference formulas, double angle and half angle formulas, if time permits, product to sum and sum to product formula briefly. So the objective of the section is to solve equations involving a single trigonometric function using a calculator, a quadratic in the form when we solve trigonometric equations that are quadratic in form, solving trigonometric equations using fundamental identities, and using graphing utility. So again, quickly reminding everyone about x squared plus y squared equals 1, the unit circle where a point has coordinates x comma y or cosine comma sine. Every function in trigonometry is periodic, and the period is 2 pi for tangent and cotangent is pi. Every function is odd with the exception of cosine and therefore secant. We have some important identities known as fundamental identities, Pythagorean identities, quotient identities, reciprocal identities. As far as graphing, a sine or cosine makes no difference. A basic sine or cosine, the period is 2 pi. We cut it into 4 equal parts, and that gives us 4 arcs for sine and 4 arcs for cosine. Sine and cosine are ultimately the same with a difference of pi over 2. So sine x is cosine of x minus pi over 2. And the period in general is 2 pi divided by the coefficient of the variable x, in this case, omega. None of the trigonometric functions have an inverse. The way they are given, we restrict the domain to make them one-to-one. They have an inverse, therefore. For sine, we go from negative pi over 2 to pi over 2. The same thing for tangent, the endpoints are not included. For cosine, we go 0 to pi. And all of them will have an inverse function. Secant follows cosine, cosecant follows sine, and cotangent happen to go from 0 to pi as well. So let's start with the basic question that we have seen even in algebra. Determine whether theta equals pi over 4 is a solution of the equation. And then how about 5 pi over 4? So if you recall, a solution of an equation satisfies the equation. Simply put, let's plug in pi over 4. Sine of pi over 4 is square root of 2 over 2. These cancel each other. It's 2. So we have square root of 2 plus square root of 2, which is 2 square root of 2, not equal to 0. Therefore, the answer is not. Pi over 4 is not a solution. We try 5 pi over 4. Now 5 pi over 4, remember, the reference arc is pi over 4. And sine of that is the same as sine of pi over 4. You have to figure out if it's positive or negative. So the value is square root of 2 over 2, but in the third quadrant, sine is negative. So the reference arc is pi over 4. The answer is square root of 2 over 2 because in the third quadrant, sine is negative, so we make it negative. The 2's cancel each other. These 2 add up to 0. Therefore, this is a solution. 5 pi over 4 is a solution. 2 sine x minus 1 is 0. We want to solve this. So sine x becomes 1/2. Right? Because you move the 1, you divide by 2. And when sine x is 1/2 in a complete revolution of 0 to 2 pi, there are two answers. Remember, the reference arc becomes pi over 6. Sine is positive in the first and second quadrant. So pi minus pi over 6 results in 5 pi over 6. So again, this is the reference arc and the answer to 1/2. Sine is positive in the second quadrant. And for second quadrant, you can say pi minus the reference arc, resulting in this answer. If you want a general solution, to each one we add 2n pi or 2k pi, depending on the text. K is an integer. This is an element of, this is how we read this. Looks like an epsilon and element of. So it belongs to the set integers. Integers meaning 0, 1, 2, go to infinity, -1, -2, go to negative infinity. All right, in this case, we move this to the other side. We make it the square root of 3 divided by 2. And this is a common arc. We know cosine theta equals square root of 3 over 2. That means theta is 30 degrees or pi over 6. If they said 0 to 360, you answer it in degrees. 0 to 2 pi, you answer it in radians. So pay attention to the way they want it. So the answer is pi over 6. So we know the reference angle is pi over 6. So that's one answer. We know cosine is positive in the fourth quadrant. So to find the next one, two pi minus pi over 6, meaning you have 11 pi over 6. 11 pi over 6. I'm going to clean this up so you can see this in a different color. All right, and if we wanted a general solution, we add 2k pi or 2n pi, and again, k or n, depending on the text. We want to solve this equation. From 0 to 2 pi, we are going to move the 1, and we are going to divide by square root of 3. We get -1 over square root of 3 or negative square root of 3 over 3. To understand how this works, first and foremost, we are going to remember the reference arc, and for reference arc, you look at the positive one, square root of 3 over 3. So if you look at this one only, that gives you the reference arc. Pi over 6. But it's negative. which means tangent is negative in the second quadrant and the fourth quadrant. So tan, let's say x is less than 0, quadrant 2, quadrant 4. Therefore, in quadrant 2, you would write pi minus pi over 6. In quadrant 4, you would write 2 pi minus pi over 6 to get those. This is in general. So from 0 to 2 pi, the angle, whatever that is, this happened to be 3 theta. So imagine it's x. So x is 5 pi over 6, 11 pi over 6. And if we wanted from 0 to 2 pi and it was x and x only, we would be done. But anytime we have a multiple angle, the only way to get all solutions from 0 to 2 pi is to follow the technique that we are going to go over. We will add to each one n times or k times their period. If it was sine and cosine, we would add 2k pi or 2n pi. If it's tangent or cotangent, we just add n pi. This is the technique. So this is the technique, everybody. Anytime you have a multiple angle like 2 theta, 3 theta, or 5 theta, whatever the case might be. And so now, in each case, we are going to divide by 3. Why is that? Because it's 3 theta. When we divide by number 3, we get 5 pi over 18 plus n pi over 3 for the first one. We get 11 pi over 18 plus n pi over 3 for the second one. So I want to make sure everybody's following this. Now, only for tangent and cotangent, it works out that you can go with the first one and let n be 0 all the way to 5. However, that's not the case for sine and cosine. So let's stick with what we do with sine and cosine. Let's stick with this, so in order not to make a mistake for those. And whatever this value is, into that you plug in a value less than that, meaning since this is number 3, you're going to put 0, 1, 2. So we're going to put 0, 1, 2. Whatever this number is, we start from 0 and we go all the way to 1 less than that. Or you can say if this is n, you go all the way to n minus. So now if you plug in 0, just as an example, if you plug in 0 here, just as an example, we're going to do this one. If you plug in 0, that gives us 5 pi over 18. If we plug in 1, it gives us 5 pi over 18 plus pi over 3. (11 pi over 18, because pi over 3 is 6 pi over 18, 6 and 5, 11 pi over 18. if we let n be 2, we get 5 pi over 18 plus 2 pi over 3. Remember, we want 18 in the denominator. So 6 times 2, 12 pi, and 5 pi, 17 pi. So just the first one gives us those 3 answers. I'm going to leave you the second part to do it on your own. Obviously, if we choose n to be 0 here, we get 11 pi over 18, and you can work on 1 and 2, and here's the answers. So a quick recap. Anytime you have a number in front of the angle, that means it's x or y or z, doesn't matter, this is a number other than 1. You must add n pi for the case of tangent and cotangent, and 2k pi or 2n pi for the case of sine and cosine to find all possible solutions. And whenever you're done, if you have any doubts, you can check. You can plug this in and see if you can come up with the correct answer. All right, we want to solve this equation, and theta is between 0 and 2 pi. Cosine is 1. We know that cosine of 0 is 1. Therefore, theta minus pi over 4 must be 0, and theta must be pi over 4. The reason there is only one solution, because cosine of 0 equals 1. There's only one solution between 0 and 2 pi when cosine is 1. Sine of 2 theta is equal to 1/2. We know that in the first quadrant, the answer is pi over 6. Sine is positive in the first and the second quadrant. For the second quadrant, we get pi minus pi over 6 or 5 pi over 6. So in other words, this is pi minus the reference arc. That's how we get that, the second quadrant. Now, since this is not 1, we need to add 2n pi or 2k pi to both cases. We are going to divide everything by 2. So we get theta equals pi over 12 plus k pi, or 5 pi over 12 plus k pi. And since this is number 2, we let k be 0 and 1 only. By the way, one might say, what about 2? If you put 2, it just repeats itself. It's 2 pi plus pi over 12. If you put 2, it's the same thing as pi over 12. That's why you go all the way to this number minus 1. So let k be 0, 1, n minus 1 if we have sine of n theta. So if this number you call it n, we go all the way to n minus 1. For example, when we plug in 0, obviously we get pi over 12 here, 5 pi over 12 here. But if we plug in 1 here, just as an example, the first one, if I go with 1, this becomes pi over 12 plus pi. And that means 13 pi over 12. So far, we have, if you put 0, we have pi over 12, 5 pi over 12, and 13 pi over 12. And over here, if I put 1, I get 17 pi over 12. And those are all possible answers from 0 to 2 pi. So again, a quick recap. This is extremely important class. If we have sine n theta or cosine n theta, in general, we go all the way from 0 to n minus 1. Same thing for tangent and cotangent, but in that case, we use a k pi instead of 2k pi. We want to solve this equation. This can be done by factoring. If anybody has any problem seeing how that works, if you let cosine be x, just for the sake of argument, if you want to go that route, if this is x, then you have 2x squared minus x minus 1 equal to 0, and you do the factoring. I'll quickly show you, but you don't have to go that route. So I have x and 2x because 2 is a prime number. And because this is -1, you have no choice but to go with 1 and -1 in some order. Okay. So if we put -1 here, +1 here, this works. And we can do this without the substitution. If we are using this, that means we let x represent cosine theta. That's the meaning of it. We don't need to do that. We can do the factoring. The first one, cosine theta, 2 cosine theta plus 1, and cosine theta is -1/2. The second one, cosine theta minus 1 equal to 0, and cosine theta becomes 1. So first, each one you set equal to 0. This means cosine theta is -1/2. I assume everybody has an easy time solving that. This means cosine theta is 1. We go back and we need only from 0 to 2 pi. So again, just to make sure we can handle this, if you look at 1/2 and find the reference arc. So if I just look at cosine theta equals 1/2 and the reference arc is pi over 3. Since I want it to be negative, cosine is negative in the second and third quadrant. So, I want to show you the detailed work. In quadrant 2, you get pi minus pi over 3. In quadrant 3, you get pi plus pi over 3. So those are the answers, which give us 2 pi over 3 and 4 pi over 3. Cosine theta equals 1 only when theta is 0. So these are 3 different answers: 0, 2 pi over 3, 4 pi over 3. So anytime you have a negative value, you can go to the positive portion, find the reference arc, and figure out which quadrant you have to come up with the correct answer. So this becomes quadratic in form. we're going to use identities, and this becomes quadratic in form also. We notice we have sine squared and sine. Because this is sine minus sine, then we change this one to 1 minus sine squared. But let's say this was cosine, then we would change this one to 1 minus cosine squared. So this one is changed. And now we bring everything to the left side. This becomes a positive. And this becomes negative. So we have 2 sine squared minus sine theta minus 1. And it's the same factoring as we did before. You can let this one be x, in which case you get 2x squared minus x minus 1 equal to 0, and factor it. Or just factor it using the fact that it's sine, not a big deal. And it's a very easy factoring because 2 is a prime number and negative 1 is just 1 and negative 1. You just got to figure out where you put them. I hope everybody's okay with that. So this will result in sine theta equals negative 1/2. Because remember, we said that equal to 0. So if this is 0 and if this is 0, this results in sine theta being negative 1/2, and this results in sine theta being 1. Now, sine theta being 1, there's only one answer, which is pi over 2. But negative 1/2, because it's negative, let's go with the reference arc. So keep the positive portion, and that gives you the reference arc of pi over 6. Since we want it to be negative, we know sine is negative in quadrant 3 and in quadrant 4. For quadrant 3, we say pi plus pi over 6. For quadrant 4, we say 2 pi minus pi over 6, and we get 7 pi over 6 and 11 pi over 6. Again, I'm showing you how to find that with details. And of course, sine theta equals 1, the answer is pi over 2. We want to solve this trigonometric equation, and there are 2 ways. One obvious way is to change one of them, either sine to cosine or cosine to sine, meaning if I want to change this to 1 minus sine squared, I can do the job. Let's look at that one. This goes to the other side and it becomes positive, so we have 4 of them. And if I divide by 4, sine squared is 1/4, and sine is plus minus the square root of 1/4, or plus minus 1/2. So we just went over sine theta being negative 1/2 in the previous page, and we know it's 7 pi over 6 and 11 pi over 6. I went over that. But for sine theta equals 1/2, obviously pi over 6 is an answer in the first quadrant. In the second quadrant, pi minus pi over 6, because remember, pi over 6 is the reference arc. And this, when sine theta is positive 1/2, and this we have seen it when sine theta is negative. Now, there is a second method I will show you, and you can finish it at home. The second method is this. Given this equation, let's just actually do it right here. Here's the second method. you can divide both sides by cosine squared or sine squared. That results in 3 tan squared equals 1. And you can solve this equation. Try it at home. Sometimes we have more than one method. All right. Since this is cosine, then we change the sine squared to 1 minus cosine squared. Since this is cosine, we will change this to 1 minus cosine squared theta. And so on the right side, we have 2 minus 2 cosine squared theta. We want to bring everything to the same side, we want to put it in descending order, and since minus 2 cosine squared is on the right, if we move everything to the left, that negative 2 cosine squared becomes positive 2 cosine squared, then 2 becomes negative, with positive 3 becomes 1. So we have 2 cosine squared plus 3 cosine theta, and this 2, remember, becomes, so we have minus 2 plus 2 cosine squared. Again, we can do this by factoring. Since this is number 2, it's very easy. So I hope everybody's okay with the factoring. And again, this is number 1, it's very easy. Or you can change cosine to x if you were to do that. Let's say this is m, just for the sake of argument. So 2m squared plus 3m plus 1 equal to 0. So you can do it by this would be taking place by substitution. You don't have to. All right, so cosine theta equals negative 1/2 here. Cosine theta is negative 1 here. So as far as negative 1 is very obvious, the answer is pi. So there's only one answer. Cosine theta is 1, the answer is 0. It's negative 1, the answer is pi, we're done. But negative 1/2, first let's look at 1/2. So I want to look at cosine theta being 1/2 in the first quadrant. The reference arc is pi over 3. Since it's negative, we've already discussed that also. It's negative in the second and third quadrant. In the second quadrant, pi minus pi over 3. And in the third quadrant, pi plus pi over 3. And we get 2 pi over 3, 4 pi over 3, and of course, theta equals pi. Again, I went over this with details because I want to make sure that if you come across a common arc, but it happened to be negative, it's not in the first quadrant, first come up with the reference arc and then figure out which quadrant you could easily come up with the answer. All right, we want to solve the equation between, and theta is between 0 and 2 pi. We know the right side is 3 cosine theta plus 3 when we distribute the 3. Since we have cosine, We're going to change this to 1 minus cosine squared. Since this is negative, we're going to move it to the right. Becomes cosine squared. And this becomes minus 1. We put them in descending order. We combine them into cosine squared plus 3 cosine theta plus 2. Again, it's a very simple factoring of cosine theta plus 1 times cosine theta plus 2. I'm assuming no one has any problem with factoring. Just quickly, you want two numbers. The product is 2, the sum is 3. That's how you get 1 and 2. So cosine theta equals negative 1, cosine theta equals negative 2, and cosine theta equals negative 1. We've done it many times. The answer is pi. But cosine theta is negative 2 has no solutions because cosine goes between negative 1 and 1. That's the range of cosine. So this has no solutions, and we use phi to represent that. This has no solutions. If it's negative 2, if it's positive 2, if it's 5, if it's 1.1, no solutions. To solve this, we notice that we are dealing with cotangent and cosecant. So what we do, we remember the relationship between the two is that 1 plus cotangent squared or cotangent squared plus 1 is cosecant squared. Therefore, since this is cosecant, we're going to change this to cosecant by moving the 1. If I move the 1, cotangent squared becomes cosecant squared minus 1. Cosecant squared minus 1. So I hope everybody's clear what happened. Since this is cosecant, then we have to change this. And it becomes, when you move the 1, becomes cosecant squared minus 1. We want to get rid of the 2. So we're going to multiply both sides by 2. So this becomes 2 cosecant squared minus 2. And this becomes 3 cosecant theta. And we move this to the left at the same time. So quickly I can put that at top. We have 2 cosecant squared theta minus 1 equals 3 cosecant theta. Move everything to the left, put them in descending order. And again, factoring is very easy because 2 is a prime number. So 2 cosecant theta plus 1 times cosecant theta minus 2. All right, this means cosecant theta equals negative 1/2. This means cosecant theta is positive 2. This means sine theta is negative 2. And this means sine theta is positive 1/2. Sine theta. Oh, I thought I did put sine here. I'm going to fix it in a moment. So this has no solutions because sine, just like cosine, goes between negative 1 and 1. And sine is 1/2 pi over 6 in the first quadrant. Pi minus pi over 6. That means 5 pi over 6 in the second quadrant. So sine theta is -2 because cosecant is 1 over sine, because sine and cosine are reciprocals. So if cosecant is -1/2, sine is 2 over -1 or -2. If cosecant is 2, sine is 1 over 2. Let's look at cases that require a calculator. So for example, when cosine is a 0.2, it's not a common arc. We don't have the answer. We want to answer between 0 and 2 pi. If we go with the inverse and using a calculator, it gives us the answer. So cosine inverse of 0.2, and we get 1.37. So this is in radians. And again, bear in mind that really when you're looking at 0 to 2 pi, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, so on and so forth. So this is one answer. But remember, cosine is positive in the first quadrant and the fourth quadrant. And because this is the first quadrant, you can treat that as reference arc. So in the fourth quadrant would be 2 pi minus this value. And there you have it. So let me just write it here, quadrant 4. Sorry, because I need that space. So in quadrant 4, theta is 2 pi minus theta sub r, the reference angle, which happened to be 1.37. So here's the explanation. For inverse cosine, the calculator will only give you an angle from 0 to pi. There's another angle in the interval from 0 to pi with that cosine value in quadrant 4. The reason it's quadrant 4, because it's positive. And so here's the angle you want to pay attention to. This is 1.37. This is the reference arc. Two pi minus 1.37 puts us in the fourth quadrant. And if you use a calculator, since they said 2 decimals, we get 4.91. Remember, pi is 3.14159, and it continues indefinitely. So you put it in a calculator, subtract this one, and you just stick with 2 decimals. In case it is not a common arc, we have two answers as follows. All right, tan theta equals -2. Again, we have the same situation. It is not a common arc, and it's between the two, between 0 and 2 pi. So when we put it into a calculator, first of all, we write tangent theta equals -2 means theta is tan inverse of -2. This is -2. And it gives us the answer, and I put it with a bunch of decimals. Then we will pay attention to the fact that we want 2 decimals. First, you want to write many decimals, then you do the rounding accordingly, which means this one next to it is 7, you take it up. So that's 1, but remember, we want it from 0 to 2 pi. That means we can't have it as a negative, okay? Why is this the answer? Because tangent has been restricted from -pi over 2 to pi over 2, and because it's -2, it will answer negative, and we want to bring it up to 0 to 2 pi. All you have to do, add pi, that gives you one answer, because we want from 0 to 2 pi. Add pi, that gives you one answer, which is in the second quadrant, because tangent is negative what? Tangent is negative in the second quadrant and in the fourth quadrant. So you add pi, puts you in the second quadrant. You add 2 pi, it gives you the answer in the fourth quadrant. So here's the explanation. For inverse tangent, the calculator will only give the angle from negative pi by 2 to pi by 2. There is another angle in the interval from 0 to 2 pi with that tangent value in quadrant 2. Therefore, first of all, we are going to round it because they said so to negative 1.11 radians. Pi minus that, and again, using a calculator with a couple of decimals, we get almost 2.03 radians. And in other words, this is the negative 1.11, okay, negative 1.11. Add a pi and gives you pi minus 1.11, which is this. And by the way, if we wanted to go with the x and y, we know the answer is 1 and -2, and we can figure the rest of the trigonometric functions. And of course, theta is 2 pi minus 1.11. In the same angle, negative 1.11 in a negative sign, if you add 2 pi, gives you the same angle, but it puts us between 0 and 2 pi because we want a positive value for that. Again, why are we doing this? Is this the correct answer? Yes, but we have two answers from 0 to 2 pi, and to bring it to 0 to 2 pi, you add pi. For the second quadrant, you add another pi, meaning 2 pi, to put it into the fourth quadrant. These angles, this one is identical location, identical to this one, but this has a positive value. So the answers are 2.03, 5.17. Simply add pi and then 2 pi to have answers in the interval of 0 to 2 pi. Okay. Simply do that. So to fix a couple of things here again. All right. So in short, just add pi and 2 pi, that will take care of the business. Solve trigonometric equation using a graphing utility, 3 cosine x plus x equals 4. For a case like that, this can't be solved like before. So this can't be solved by previous method, but can be solved using a graphing calculator. So you can say the left side is y sub 1, the right side is y sub 2. By the way, if you want to move that to the other side, it's easier. You can say y sub 1 is 3 cosine x, if you move that, and y sub 2 is 4 minus x. It doesn't matter. You're looking to find the intercept. So you graph it. So 3 cosine x plus x, and then 4. If you graph it, looks like this. And you want to use the intersect to find solutions. How do you find the intersect? I have the command here. You press calculator, second trace, choose intersect, which is number 5. For the first curve, hit enter. For the second curve, hit enter. For the guess arrow to the intersection and press enter. The TI-83 will return a value for x and y. Both of these coordinates are part of the solution. So when you do that, So you go to calculate, click on 5, brings you this, and as you go through this process, it retains this value. And so what is x? This is the value. How many decimals? 2 decimals. So 4.53. So x is 4.53. As I mentioned, you could do three cosine x equals 4 minus x and graph that. And if you put it in that format and graph it, it looks like this. So second trace, you bring it down to the intersect. This is one of them, let's say. You enter. Second curve, enter. And it gives you the answer. As you can see here, the answer is just what we have here. This is a different graph because I used 3 cosine x and then 4 minus x, but it gives you the same answer. So a second methodology. All right, we want to solve this trigonometric equation. Again, between 0 and 2 pi. It's a simple factoring because 2 is a prime number, 1 is 1 times 1. So it's 2 sine theta minus 1 sine theta minus 1. We've seen similar questions. Either this one is 0, makes sine theta 1/2, or this one is 0, makes sine theta 1. So if this is 0, sine theta is 1/2. This one, sine theta equals 1. We've done sine theta equals 1/2 many, many times by now. We know theta is pi over 6 in the first quadrant and pi minus pi over 6 or 5 pi over 6 in the second quadrant. And sine theta is only 1 when theta is pi over 2. Therefore, those are the possible answers.